So welcome everyone. We're in the second workshop of the day today. We're going to be talking about building on Arbitrum Stylus. So if some of you were there in the previous workshop, building on Arbitrum 1, Stylus does belong to the same Arbitrum family of products, but it is very different. And in fact, it's quite one of a kind. So I'm excited to talk about this. If you have any questions, feel free to message in the chat. I am looking at the chat. We'll be answering questions as we go. So, what is Arbitrum Stylus? Arbitrum Stylus is, we'll go over this diagram. We'll break down this diagram, right? The TLDR is that Arbitrum Stylus gives you EVM plus. What is EVM plus? So let's look at the left side of this chart. What is the EVM? The EVM is basically the execution environment for smart contracts on Ethereum, right? So developers will write Solidity. The Solidity gets compiled down into EVM bytecode. Then on sort of a chain on a node, let's say on an Arbitrum Nitro node, like the Arbitrum 1 rollup, for example, the EVM execution environment exists over there. So it can run the EVM bytecode inside of there. And like execute functions on like different smart contracts and so on and so forth. So this is regular EVM. Stylus is an upgrade to the Arbitrum Nitro stack that we were talking about earlier as well. It is the tech stack that powers the Arbitrum 1 rollup, Arbitrum Nova, Arbitrum Orbit chains, and so on. And what it does is it basically adds a second virtual machine that runs in parallel to the EVM. So instead of just having the EVM, we now have two virtual machines. There's the EVM, and then there's a new WebAssembly virtual machine. And because of the WebAssembly virtual machine, what becomes possible is now you can use any programming language that compiles down to WebAssembly to also write smart contracts. So in EVM Plus, we have the usual EVM pathway where we write in Solidity, it gets compiled into bytecode, and you run it in the EVM. But then you can also write contracts using any language that compiles to WASM. So things like Rust, C, C++. This isn't a full list. Like technically, you can use a ton of other languages as well. You can use Golang, you can use AssemblyScript, you can use Kotlin, any language that can compile down to WebAssembly. You can use any of those languages, get the WebAssembly bytecode, and then deploy that. And then the chain can actually execute the WebAssembly bytecode as a smart contract. So EVM Plus is basically a purely additive improvement to the EVM. We call it Plus because there's zero compromises being made to the EVM itself. Like nothing is being removed from the EVM. It is EVM Plus because it only adds new features. Nothing about the EVM itself changes. You can still use Solidity. You can still deploy like normal EVM contracts. There's no changes to any of that. But we're purely adding new features to let you deploy contracts in Rust, C, C++, any other WebAssembly language, and they can run in parallel to normal EVM contracts. Also, they're interoperable. So your Solidity contracts can call functions on contracts written in Rust, let's say, and vice versa. So like a Rust contract can call functions in a Solidity contract. So they're fully interoperable. Everything works together seamlessly. And it basically allows for some crazy new things to happen that weren't really possible in like the Solidity environment and the typical EVM environment. So this is effectively the overview of what Stylus is. We're going to dig a little bit deeper into how you can get started building on it, but this is like the main thing you need to understand about Stylus. It gives you the EVM Plus, adds additional features to the EVM to allow you to write contracts in any language that can compile down to WebAssembly. By having a WebAssembly VM, as I said, you can use any of the languages you can see on this picture over here. All of them are WASM compatible. JavaScript, TypeScript is a little bit hard. Only a subset of those features technically are WASM compatible. You do need a subset called AssemblyScript. But other things like Rust, C++, C, Golang, Java, Swift, Kotlin, PHP, Ruby, Ruby and Python are again a little bit harder, but the static type languages like Go, C, C++, Rust, Java, Kotlin, and Swift, these are the easiest to get working with WebAssembly. The other dynamic languages, they're slightly harder, but technically possible. All of them can compile down to WebAssembly. And in fact, like even more languages in the future can be added. So languages such as Cairo, which is used in the StarkNet ecosystem to write contracts, languages such as Sway, which is used in the Fuel blockchain ecosystem to write contracts, or languages like Move, which is used in SUI and Aptos networks. They can also be added in the future because like technically they can also compile down to WebAssembly, and they can also be added in the future as a way to like deploy contracts to an Arbitrum Stylus runtime. Again, Stylus is executing WebAssembly bytecode, right? Like the EVM plus, like this WebAssembly VM over here, it doesn't really care what the original language was, because all it really cares about is getting the WebAssembly bytecode, right? Similar to the EVM, like Ethereum doesn't care if you're writing your contracts in Solidity or Viper or Huff or Yule or any of these other things. All it really cares about is the EVM bytecode that actually gets deployed. So the list of languages technically you can use in Stylus is like never ending, because all you really need is the WebAssembly bytecode, and the WebAssembly bytecode, like it doesn't really care about which actual language was used at the top. Um, and again, like compared to Solidity, WebAssembly is a lot more efficient. Um, the reason for this is that languages such as C, C++, Rust, and so on, they've had decades of compiler development, right? Like C, C++ have been around for literal decades, and a lot of work has gone into making their compilers as efficient as possible and as, like the best performance is being squeezed out of them. So being able to use a WebAssembly virtual machine just by the nature of using those languages tends to result in more efficient bytecode and more efficient contracts than anything like Solidity or the EVM can offer. On an average, a 10 times improvement has been seen using WebAssembly compared to contracts that are using Solidity when deploying to Stylus. So 10x improvement is pretty big, I think. So just by using a WASM runtime instead of the EVM runtime. Um, so why should you care about this? Number one, obviously, one chain, many languages, right? Um, as of today, they're estimated to be about, like 20,000 Solidity developers out there, but there's like 3 million people doing Rust and like 12 million people doing C. So by enabling like a WASM VM, devs can now use whatever language they prefer, and they all can work on the Arbitrum chains through Stylus without needing to they're interoperable with existing code, they're interoperable with Solidity. They don't need to necessarily learn anything new, and it just opens up the playing field to a lot more devs. So even for like some hackers over here, if you're relatively new to the Web3 space, but maybe have been coding for a while, like this does allow you to, go do your smart contracts in a language you might already be familiar with instead of going and learning Solidity first. So that's reason number one. You should care about this. Reason number two to care about this is, and EVM plus, we've talked about this, but devs continue to get all the benefits of the EVM. So the entire ecosystem that's built around it, Solidity libraries, tooling, standards, etc., all of that exists continues to exist, right? We're not replacing the EVM. We're only adding new features to it. So let's say you want to build a project that is, a somewhat complicated project that might be easier to do in something like Rust, like it's better suited for a language like Rust. Um, it is possible to, build a project where like part of your code base you're deploying in Rust, for the complicated stuff, and then part of your code base you're writing in Solidity for to follow like standards, right? So like let's say like you're doing an NFT contract, like the ERC 721 part of it, you can do in Solidity and you can use a standard ERC 721 implementation. But then maybe you're doing some really complex like generative art thing that is better suited for something like Rust, where it can more efficiently do more complex calculations. So you do like part of it in Rust and then part of it in Solidity. So it really like again increases the playing field and allows things to happen that would be really hard or really inefficient to do in Solidity. Um, it also has opt-in reentrancy, so it's not just an improvement on the speed or the cost or the efficiency. WebAssembly programs are also safer. So like reentrancy, for example, it's a common issue that Solidity devs face and try to mitigate when writing Solidity contracts. Stylus can detect reentrancy, and if you're using the Rust SDK for Stylus, reentrancy is actually disabled by default, and you have to intentionally override it if you want to enable reentrancy for whatever reason. So through Wasm, Arbitrum team, and like the Stylus team, they've built like a lot of provers, WebAssembly provers, and they can detect if reentrancy is happening. And by default, reentrancy is disabled, and you have to manually enable it if you need to for whatever reason. Um, and and yeah, it's fully interoperable. So all Solidity contracts, existing contracts, any new contracts, everything, it all works together. So you can call functions from Solidity to Rust, from Rust to Solidity, whatever. It all just works. Um, so tons of possibilities, right? I will say at this point, technically, even though you can use any language you want with Wasm, the best support for this currently is with Rust. So the Stylus, with Stylus, there is a Rust SDK that you can use to create smart contracts in Rust. So you do have to use that SDK, and technically, again, any language can be used, but the Wasm bytecode that is output, it needs like some special things so that Arbitrum can understand it. So if you're planning on doing it, the Rust SDK is the most mature. There are other implementations for other languages, but the Rust SDK by far is the most mature out of all of them. And as we'll see later, one of the potential bounties, actually, um, one of the things that would be amazing if somebody builds it in the hackathon would actually be adding support for more languages. But we'll get to that later. Tons of possibilities. Um, so let's look at some examples. Example number one, custom cryptography libraries. So Ethereum, for example, only supports ECDSA signatures. But for many different reasons, you might want to support alternative signature algorithms, alternative cryptography algorithms. So for example, one example I can give you is, let's say you're building an account abstraction wallet, right? You're building like a smart wallet, smart account. Now, in a smart account, maybe what you want to do is you want to get rid of the concept of private keys, and instead you just want the user to use Face ID. So let's say it's like an iOS app and you want the user to simply do Face ID, and you use the inbuilt iOS cryptography that is used by Face ID to sign transactions, right? Sign user ops in your smart account. So to do that, it is possible to do that, but the problem is the signature scheme that Face ID uses is not what Ethereum uses. It uses this other signature scheme called SecP256R1, I believe. Um, so there have been efforts, for example, to like add support for other signature schemes to Ethereum through the use of like smart contracts. Like somebody made a smart contract, it's there on GitHub, where they implemented like the cryptography library as a Solidity contract, as a Solidity library, and then you could use it. But that's not really the kind of thing you want to do in Solidity. It's so expensive in terms of gas to do that. Um, it's kind of like, you know, it's so expensive in terms of gas to do that, they kind of like lose out on a lot of benefits. Like it costs a lot to verify those signatures from a Solidity library. Um, but something like Rust or C++ for that matter is a perfect language to do cryptography libraries, right? Like signature schemes, cryptography, like all of these are systems programming languages, and they're perfect for doing cryptography libraries. And there's a ton of open source implementations of a ton of different cryptography algorithms in all of these languages. So you can have a custom cryptography lib in Rust and then create like a smart account that uses the custom cryptography to build like Face ID wallets, for example. Like that would be pretty cool. Um, there are a few questions in chat. We'll take those towards the end. We'll do Q&A towards the end. But okay, so custom cryptography libraries possibility number one. Number two, generative art. So this could be like art that is like programmed, right? So you have some code. Yeah, I don't know if you guys have heard about art blocks. It used to be very famous like a couple of years ago, but the idea is like it like given some random input, like some sort of initial seed, you can use that random input to create some image programmatically. So this photo on the screen that you see right now, this is a very famous generative art project, Tyler Hobbs Fidenza. In the peak NFT market, these were going for like millions of dollars each. But basically, the idea was like all of these are created from the exact same code. It was just with different inputs, like the different random numbers being input to it. So what happens is this is still a fairly simple generative art project. Like the code for generating fidenzas, it was a few hundred lines long, but there's a possibility to do like, there's a ton of like Web2 websites you can go to where people have done like absolutely insane generative art projects. So you give it some random string as input and we'll do some absolutely crazy shit. And do like some insane, uh, draw some like insane art for you, all based on like some sort of like 3D rendering algorithm or like even like a 2D algorithm. Like this is a 2D algorithm. So the thing is, as you get to more and more complex generative art uses, you need, your memory requirements become higher. You need to do a lot of calculations, a lot of processing. And again, with Solidity and gas and how it works, like it's not the most optimal to do complex stuff like that. Um, in fact, even these fidenzas, these weren't done as Solidity code. I won't get too much into how art blocks used to work, but even this wasn't done inside Solidity directly. But again, use WASM. We use a language that is more efficient. And use Rust, use C, use C++, whatever, and then you can do some really cool generative art things, and then just create ERC-721 contract and Solidity, but leave all the heavy work off to like a Rust library or something. Cool. Number three, porting existing C++ games on chain. Who wants to run Doom on Arbitrum? Um, I'd love to see this happen, just personally. People have run Doom everywhere. Um, I saw somebody running Doom on a thermometer. If you don't know what Doom is, I don't even know, bro. I think you need to be on the internet a little bit more. But um, no, the Doom is this like really old game. One of the first video games that really made it, right? And it's a really lightweight because it was written like 30, 40, 50 years ago. So it's actually a really small game. So over the years, people have gotten Doom to work everywhere. There's people running Doom on a thermometer, like the little screen on a thermometer. Imagine how much computation power a thermometer has. It barely has any, right? But even then, like you can technically run Doom on a thermometer. So you can run Doom like anywhere, really. So like with Stylus, it's a C++ game. Um, Run it on Arbitrum, right? Port Doom on chain. Or Doom is just like one example. You can do this with a variety of different games, right? Port Doom on chain, do some stuff, modify some Doom code to like if you like however many enemies you kill, whatever, mint an NFT, like create like a leaderboard, on-chain leaderboard of people who are playing these games, whatever. So port games on chain, cool use case. Um, and yeah, there's this quote with somebody from the Arbitrum team where the most exciting part about Stylus is all the novel use cases that haven't even been dreamt of in the EVM, because none of this was possible before Stylus, right? It was very inefficient. EVM was limiting. It simply wasn't possible at the time. So Stylus opens up a whole world of possibilities, and even the three, four examples I gave you, they're really like stepping stones, right? If you use your imagination, I'm sure you guys can come up with a bunch of more cool use cases. So keep that in mind. So we'll quickly go over how to set up a Stylus project in Rust. Um, and we'll look at like sort of it's actually really simple. Like you don't really need to do much. We'll just look over like the basic Hello World template, and we'll compare it to how it looks against like a Solidity version of the contract, right? You don't need to follow along. You can watch this later. This information is also available on the Arbitrum documentation. Um, just just focus on the presentation and ask questions. Don't need to follow it along right now. So the only prereqs here is you must have Rust installed on your computer and have some sort of code editor like VS Code, right? Um, Once you've installed Rust, um, security first, create a new testnet account that has no funds on mainnet because you're going to be using the private key to deploy your contracts. So create a new testnet account with no mainnet funds. I don't want anybody leaking their keys and losing money. And then get some testnet tokens. You can use the Learn Web3 faucet to get some tokens on Arbitrum Sepolia for this. And then we'll do Q&A at the end. I'll get back to those questions in a bit. But yeah, get some testnet tokens. So what do we need to do? First of all, install the Stylus CLI. The command for this is this. The key part is really like cargo install cargo-stylus. The rest is you need to set this environment variable. You can copy this from the Arbitrum documentation, but cargo install cargo-stylus. Cargo, if you guys don't know, if you're brand new to Rust, cargo is like it's like Rust's package manager. It is how it's like if you're used to like JavaScript, it's like npm, right? Or in Python, it's like pip, but more powerful. It's actually more than just a package manager. It does a lot of things, and one of the things it can do is it can install packages for you. It can install like things for you. Link to the docs. Yes, I will. I have the link to the docs in like a couple of slides later. I just want to go over like the simple process first. So the first thing to do to set up a new Stylus project is install the Stylus CLI. So cargo install cargo-stylus, and then you need to add a WebAssembly target to Rust. Again, don't worry about this too much, but essentially what this means is you're telling Rust that I want to compile my Rust code for a WebAssembly runtime, right? Like, because typically by default, Rust can only compile code to the runtime of the computer you're currently on. So if you're on like a MacBook, it will compile it for like Mac OS. If you're on a Windows machine, it will compile it for a Windows machine and so on. And if you want to compile for targets other than your native, you need to tell it to do that. So once we install the Stylus CLI, we also tell Rust to add the WebAssembly target so it can compile it for a WebAssembly virtual machine. Anyway, once we've installed the CLI, now it's simple. So you go to your terminal, you do cargo stylus new hello world, right? Um, this will set up a basic project for you. So this last thing over here, this is like the name of the project you want, and then cargo stylus new is what will set up the new project for you. And essentially, the main file it will create is this. So under the source folder, src/lib.rs, this is like the main file this will create. If you've ever used Foundry or Hardhat to set up a new Solidity project, or like even like Remix, you know it, like when you start a new project, it comes with like a default counter.sol, right? Like the super simple Solidity contract where you can there's a number and you can get the number and you can set the number, right? There's a simple counter contract. So when you set up a new Stylus project, this is basically the counter contract, except it's in Rust. So there's two things we're mainly looking at over here. There is the top part, the storage block, and then at the bottom, we have the smart contract implementation itself. So at the top part in storage, we define the struct counter. So pub struct counter, it's a public struct counter, which defines all the values, all the storage that your smart contract needs. So this is like global variables, right? So in the counter contract, we just need a uint 256 called number. And then we go down to the actual implementation of counter. And now this has three functions in it. As the first, a public function number that returns a U256, which is a uint 256. And this is as simple as just self.number.get. So self refers to the struct, right? And self.number means this number variable inside the struct. And then you're doing dot get to get that value and return it. So this is like a view function, basically. This is like a read-only view function, basically. And then we have two functions that actually update the state. So there's the public function set number, which takes in a new number value, U256, and then does self.number.set new number, self-explanatory. And then we have the pub fun increment, which gets the current value of the number and then sets it to be number plus one, right? Number plus U256, one. So like, why are we doing this U250 stuff here and there? It's because it is Rust. So we need like some conversion between Rust data types and Solidity data types. Like Rust by default doesn't support uint 256. Like that's a pretty large value. By default, it only goes up to like U64. So for values greater than U64, there's like these special data types that come in the project. I actually hid away some code from this file, like at the very top. That is not part of the screenshot. There's some imports, like there's some files being imported that get set up when you set up this project. And inside of these imports, there's this thing called U256. And that U256 is like a wrapper data type that converts between Solidity and Rust data types. So the point is, though, that this is fairly readable. If you've ever done Rust before, this is going to be extremely readable to you. If you haven't done Rust before, even then, it's probably not like particularly hard. You might be confused about some stuff, like what the hell is and mute self, but that is normal if you haven't done Rust before. But I won't spend too much time talking about that right now. But if you have done Rust before, even if you haven't, like apart from maybe a couple of tiny little things here and there, it is a fairly readable piece of code, right? Um, so you have this contract. Now, how do we deploy it? So first of all, we do cargo stylus check. This kind of, this kind of like compiles the contract, makes sure there's no errors, any compilation errors or whatever. So you do cargo stylus check. And if it gives you any errors, you go back and fix those errors. If there's no errors, you continue. And then what you can do is you do cargo stylus deploy, and you give it dash dash private key path equals like a file path. So the testnet account that we set up earlier, you take that testnet account, you take its private key, and you save that private key to a file. And you keep that file in git ignore. Don't push it to GitHub. You keep that file in git ignore, you save it to a file, and then you can do cargo stylus deploy dash dash private key path equals the name of that file, or like the path to that file. And once you do that, your contract will be compiled and it will be deployed to the Arbitrum network, and it will tell you the contract address. So that's it. Like literally, like not a lot of complications. You set up a new project, you get this contract, you change around whatever stuff you need to change around, you build it, and then you deploy it. No super complicated stuff going on. If you've done Rust before, going to be very easy. If you haven't done Rust before, slightly less easy, but also not like too difficult either. Um, might be a good excuse to finally learn Rust because I know every other person I meet is like, I really want to learn Rust, but they don't have a reason to. Like they can't, they can't find a reason. Everybody keeps saying I want to learn Rust, but never does. So maybe this is your signal from the universe to actually go and learn Rust now that you have an excuse to do it. So yeah, but anyway, um, and yeah, so for the hackathon, if you're building on Stylus, you're eligible for both bounty categories because we have one bounty category dedicated for people building on Stylus for $6,000, and then bounty number two is just best apps on Arbitrum overall. Also, keep in mind that it is possible to win both bounties from a single project. Like it is possible you build a project on Stylus that gets a prize from bounty category one and also gets a prize from bounty category two. So technically, you have access to the full $15,000 prize pool, and the maximum prize you can win as a single project is $7,000, is first place on both. Definitely check it out. I'll build on Stylus if you want. There's some ideas over here I have. Let's go to the Q&A first before I get into the ideas. So we have a bunch of questions in the chat. If Solidity is slow compared to other languages, why is it still being used in the EVM? Honestly, a big reason is backwards compatibility at this point. When to be fair, like Rust has matured a lot over the last few years. And back when Ethereum first came out, like Rust wasn't really a viable option to have as the smart contract language. And at the time, it made sense to do Solidity as a way to like, have like custom ways of doing like blockchain specific stuff that would be harder to do with other languages at the time. But over time, the reason it has stuck around is backwards compatibility because removing Solidity or removing the EVM now is a thing that puts trillions of dollars at risk on the Ethereum network. So it's just not worth it. And Ethereum L1 likely isn't going to get rid of Solidity anytime soon, but that is why layer twos like Arbitrum with Stylus are innovating on this to get away from it and introduce new paradigms. And Stylus isn't the only one, right? Like if you look at the Starknet ecosystem, for example, they use Cairo, which is a language they made, and then the Fuel ecosystem uses Sway, which is a DSL based on Rust. So newer L2s and newer ecosystems that are improving Ethereum and scaling Ethereum are adding support for stuff other than Solidity, but the layer one itself, we're likely not going to see that change anytime soon because of how technically complicated a change like that is and the fact that it will put trillions of dollars at risk. So it's just best not to do it at this point. Um, how to not write spaghetti code in Rust? Um, I don't know, bro. It's my philosophy with Rust is always write the fastest way possible, like do a bunch of dot clones and just do dot unwrap and don't do any error handling the first time I'm writing some piece of code and just get it to work first. But once it's working, that's when I go back and do like proper error handling and not just unwrapping and just forcing everything and actually like checking actually having like math statements and everything. But I do all of that later. Like initially, I just dot clone and dot unwrap everything. Just no handling at all. Seems that Arbitrum with Stylus has now become a competitor to Cartesi. Not really. Cartesi is quite different, where like Cartesi does app chains that have a full Linux virtual machine accessible to them. I would say Stylus, if anything, is like less capable perhaps than what Cartesi is. I think Cartesi, uh, you know, Stylus intends to main compatibility and interoperate with Solidity contracts as well, right? The goal for Stylus is to let people deploy smart contracts that work with other Solidity contracts as well. So Cartesi is a completely different. Cartesi is your dApp will have its own chain with a full Linux VM accessible to it. So I don't think they directly compete, but it is an example of like L2 is looking to scale Ethereum, exploring new paradigms and languages other than Solidity to help it scale. Let's go over some ideas on what you guys can build. Idea number one, this is what I was talking about earlier when I was talking about cryptography libraries, but account abstraction. So you can import like you can build like cryptography libraries in Rust. Things like SecP256R1 if you want to do Face ID support, or other cryptography libraries for other things, whatever you might be interested in doing. Have those cryptography libraries come in from Rust land, and then create a smart account that allows you to sign transactions through that. So you don't like end users don't need to worry about managing their private keys or seed phrases. Their face ID or touch ID or whatever is their private key. So their private key is stored securely inside of their iPhone or whatever, Android phone, whatever. And they're not like us plebs who are exporting their private keys on MetaMask and trying to keep it safe on a piece of paper or whatever. Um, so their phone is their private key, and then they can just use that and have like an account abstracted wallet and do whatever they want on chain and never have to worry about keeping their seed phrase on a piece of paper. So that's number one, cool stuff you can do. Number two, on-chain art, as I said, we talked about this earlier. Develop some complex randomized on-chain art. You can also do like generative art here with AI, perhaps integrating with some other sponsors, or you can do like you can use like a decentralized DB and build like some really complex on-chain art, have like a big random seed coming in. There's a variety. Like if you just Google, like after this workshop, perhaps if you go and Google for like things like p5.js, or there's this language called processing, like the name of the language is called processing. Search for that on Google, search for like p5.js generative art, or search for like processing generative art, things like that. And these are like specialized frameworks and languages designed to create generative art, both 2D and 3D. Um, it is, by the way, like generative art and things like that is also how like somebody was talking about Minecraft earlier. It is also how like Minecraft worlds are generated, right? Like if you've ever played Minecraft, what happens is like when you start a new game of Minecraft, you give it a random seed, you give it like some random number, and it generates an entire world for you. With like some places there's water, some places there's animals, some places there's mountains, whatever. So what's happening is it's an algorithm that based on the random input you're giving it will give you like this whole random world, right? And as long as it's the same input, if you give it the same number, it will generate the exact same world. So it's like deterministic generative art. Only Minecraft does it in like a 3D manner. You can do 3D, you can do 2D, but things like that take a lot of like memory. It requires a lot of computation, a lot of mathematics, as you're like trying to figure out what this entire massive Minecraft world will look like. Um, so really well positioned for like a language like Rust or C or C++ to be responsible for doing stuff like this instead of trying to do it in Solidity. So on-chain art can be made like from very simple to extremely complex really fast. There's a bunch you can do over there with Stylus, and definitely more that you can do with just Solidity. Number three, on-chain games. So we talked about this in Arbitrum 1 as well, but Arbitrum 1 on-chain games are cool, but in this case, this is slightly different because as we were talking about earlier, you can now port or modify like existing older games like Doom and get them to run, or like get a version of them, for example, to run on Stylus. So like you can have like Doom running in a web browser, and then you can have like parts of Doom, like whatever is necessary, perhaps for like calculating the person's score or whatever. Maybe you can have part of that in like Stylus somewhere, and then you can use that to create like an on-chain leaderboard. Whatever. Like you can use Stylus to you know, port over existing older code, whether it be from games or from other things, and create on-chain experiences that would be very hard, if not impossible, to do in Solidity. right? Like obviously you probably don't want to run the entire game on chain. I don't even see how that would work. Like, what are you going to do? Like every transaction moves the player forward by like one step. Technically, I guess you can do that where you need a transaction for every move in the game, but maybe actually what you want to do is have like the game running somewhere in like a browser or something, but have like some core logic of the game beyond chain, which you can use for like actually tracking points and whatever, right? So doing stuff like that becomes possible now with Stylus. Number four, this would be really cool is like language support. So obviously we have the Stylus Rust SDK. If you go through the Stylus documentation, link is on the next slide. I'll show you in a second. But there's obviously the Rust SDK. But if you look in the documentation tells you um, how to use like a general WebAssembly language and deploy it to Stylus. Like the SDK obviously makes things easier within the Rust ecosystem, where you can just do cargo Stylus new project and it will just set everything up for you. But other languages like C, C++, Golang, etc., you can still use them. It's just, it's not as easy as the Rust process, but it is still possible. So one thing that would be awesome for this workshop, sorry, for this hackathon, is creating those SDKs, right? Creating the helper dev tooling necessary to support, like, well, not support, but make it easier to use languages other than just Rust on Stylus, right? Uh, so yeah, these are four ideas off the top of my head. Again, this is not an exhaustive list. There's a lot more you can do. So use your imagination. Feel free to do anything else. This is not a required list. This is just inspiration. So at the end of the day, do whatever you wish to do. But hopefully, this gives you some ideas at least on like how to start thinking about it. In terms of resources, docs.arbitrum.io/stylus has all the information about Stylus that you need. You can use our faucets for the Sepolia, Arbitrum Sepolia testnet funds. You can, again, like under Stylus, you'll find the Rust SDK guide, which goes into detail about the Stylus Rust SDK and all the features and capabilities. If you have any questions that we, for some reason, are unable to answer in the Learn Web3 Discord, you can always reach out to the Arbitrum Discord as well and get help from there.